Hi dear students, let's see this question that was asked from the topic of motional EMF. In this question we have a circuit, you can see like this. This circuit has zero resistance. A part of this circuit is going inside, like a magnetic field is going inside this over here, constant magnetic field. Okay, let's assume the value B for the time being. Now the circuit is being pulled towards right at a constant velocity V. Okay, it's also given that the inductance of the circuit is L. So let's say we have an inductor here which is of length L. At time 0, the left end of the circuit was at the origin. So this part of the rod was over here. Okay. So we have to choose the correct graph between current flowing in the circuit and the distance x between the left end and the origin. Okay. So I'll show you, these are the four options. Okay. I'll show you the situation again. Okay. So the situation is shown like this. This is the left end of the rod. This is the coordinate system. This is the origin. Okay, I'm showing you this situation at time t. Okay, so the constant magnetic field B is going inside and we are pulling this end with velocity V. The self inductance of the circuit is L. Okay, so we have to choose the correct graph between the current and x. Now what is x? X is this distance between the left end of the circuit and origin. Okay, now because of motional EMF we can say that there will be the induced EMF over here whose value can be given by BVL. Now L is W actually here, this length is called as W. Okay, so the length of this part or this part we can say is W. So BVW will be the EMF induced. Okay, the polarity can be found out by V cross B. So velocity vector is in the rightward direction and magnetic field is going inside. So if you see V cross B, so thumb will point towards the positive y-axis and hence this will be in the positive uh, pole. That means the ये positive polarity पे होगा. ठीक है. Now current I will flow in this direction because this is the type of polarity. तो current I ऐसा flow करेगा clockwise direction में. So if you apply the Kirchhoff's law का equation on this circuit, let's start from here. BVL का rise, BVW का rise. Okay, and if you cross an inductor, so we will have a drop of LdI by dt. Whenever you cross an inductor, the potential drops by a distance by a value of LdI by dt. Okay, so this will be the equation of Kirchhoff's law. Velocity can be written as dx by dt. Okay, and this is W. That should be equals to LdI by dt. Dt and dt can be cancelled, and we can integrate this. At time 0 when x was 0, we can say that current, let us say, was I naught, and after a while current becomes I when x becomes x. So LHS will become BWX and RHS will become L into I minus I naught. So this gives us I is equals to I naught plus BWX upon L. Okay, so you can see that this is a straight line function and with a positive slope. Okay, current and x graph is a straight line function with a positive slope, right? So if you go back to the options, so option C will be the correct answer. This is a straight line function with a positive slope. So this C is the correct answer over here. Okay, and one more thing, some of you might think that after a while this rod will come out of the magnetic field. This thing will come out after from the presence of the magnetic field. So we don't consider such cases unless and until it is specifically mentioned in the question. We have to assume that this magnetic field extends till a very long distance. That means, we don't have to consider that case where this rod will come out of magnetic field unless and until it is specifically mentioned or asked in the question. Right? That's it. Thank you.